So my name is Malvinder, and I'm working for Kuraray as a senior technical program manager for the PVP division of Kuraray, and I'm based out of New Delhi. And the topic for today's discussion is, are thinner and lightweight security glazings possible? So for a moment, you might be thinking that, how this topic is related to the theme of today's today's webinar. Yeah, I would say it's definitely linked to that, because when we talk about the future of facades, like how the future facades will look like, then I think it's very important to touch on the topic of security, because in the past few decades, security has become a big concern, and especially the infrastructure buildings that have become the soft target of so many incidents of terrorism. And that's why it's very important to talk about security. And we will see that how Kuraray's advanced interlayers are actually helping make the facades lighter and thinner. Yeah, giving the introduction of like who we are and what we do. So we are the leading manufacturers of the different interlayers for laminated glass applications. The different applications have been highlighted on your screen, starting from safety, decorative, acoustic, structural and security, and specialized applications of laminated glass. But for today, the focus is on security applications. And we will see that how the advanced interlayers from Kuraray, they are helping the facades become leaner and thinner. Security has become a new trend for the facades, as we have seen, as we can see at the global map. Very few countries have been actually spared from the incidents of terrorism in the recent 2 decades. Countries as far as New Zealand, they have also been affected by the incidents of terrorism, and even the Singapore government has also been talking about making their airports facades which are resilient against blast attacks. And on the right-hand side, you can see the picture of Brussels airport, which was attacked in 2016, and the below is a aftermath of what happened. You can see the people. They may not have been injured because of the direct impact from the blast, but actually the glass shards. Those caused some grievous injuries to the people in the vicinity of the airport. So in those type of situations, glass actually becomes a secondary weapon, which can be very, very critical for the design of the facades. And also, we have seen not only the rising incidents of terrorism, but also the civil unrest has been growing in many parts of the world. It could be political unrest, social unrest, or the reason could be anything, but we have seen that often the corporate buildings, the big fashion brands, they become the soft target of the mobs, and this is mainly because layman thinks that glass is a very weak element of the building, which can be broken very easily, and people can loot or cause destruction to the building, or cause loss to the property by just damaging the glass and entering into the building forcefully. And then this poses a great amount of challenge for the designers to come up with a facade that that can actually sustain those attacks. And then there is another trend that architects, they love to have big glass panels with minimal frames, and this is putting an additional challenge for the designers to design glasses which are capable of sustaining those kind of attacks. When we talk about security glazings, then it's important to remember that the intent is to protect damage to the property from man-made attacks, or it could be natural hazards as well, like in case of hurricanes, or like there could be floods. Then the primary attack from the threats is actually borne by the facade of the building. So we with a proper design combination, you can make the facades resilient for those kind of attacks. So before we go into the deep subject of security glazing, it's important to understand the behavior of the glass and the different breakage patterns. Why it's important? Because sometimes people end up making the mistake of using the wrong type of glass for security applications. So the breakage pattern is very important, and the annealed glass is on the left hand side, which breaks into big shards when broken, and it can cause grievous injuries. It's not even a safety glass. And then we have the tempered glass, which breaks into small fragments. It's a safety glass as recommended by many of the country standards. But it would be wrong to say that it's a security glass. Many people they say that I have put up the strongest glass in my house or in a building, and but it's not making you secure. And then we have the laminated glass, which is the best safety glass that you can have. But I would say it's the entry level of a security glass, because the safety level or the security level that will be provided by the laminated glass is actually determined by what is in between the two layers of the glass. So which means the thickness of the interlayer is going to govern the level of security that you will get from the glass. Here, more clear comparison of what are safety glazing and security glazings. It's important to remember then when you are when the intent is just to protect the people from injuries from the glass, you need safety glass. But when you are trying to get more from the glass and you want to prevent the people from breaking in, forcefully entering into the building, then you definitely need a security glass. And here the intent is to increase the break-in efforts or the time that is needed by a person who is forcefully entering into the building. And the security glazings, they should not be confused as a standalone solution, because here we are trying to gain more time so that secondary alarm systems, they get activated, and eventually security glazings are made of man-made materials, and every man-made material can be destroyed. So that's why we make it very clear that this should not be confused to be a standalone solution. And then next important point that I need to highlight is never ever consider tempered glass for security applications, because the breakage pattern, as we have seen in the previous slide, that is very poor for a security glazings, and you will have a wet blanket effect if you use that. Yeah. And lastly, the design of a security glass is influenced by the anticipated threat level. So you or your client must have a very clear idea about the anticipated threat levels. So what is threat level, we will talk about in the coming slides, and whether SPAL is acceptable or not. SPAL is like the risk of injuries to the people who are sitting next to the glazings. So this is relevant for the BRG applications or the bullet resistant applications. So we will touch that topic also in very detail in the coming slides. Yeah. Here we have some pictorial illustrations of what are the man-made threats. Like first we have forced entry. When somebody, a thief or robber, is trying to enter into the property, trying to steal something from the building. So you need to have a burglar resistant glazing over there. Then the higher level attack is a firearm attack, when the attacker is like carrying some firearms. The example could be again private buildings or some government buildings or some banks. And then we have a higher level of threat, which is a bomb blast or an explosion happening outside the building. So last year we saw what happened in Lebanon, when some explosives were stored around these buildings, and these caused catastrophic damage to the facades of the buildings. So when we have to mitigate the threat from these kind of attacks, you need security glazings, and these have to be designed properly with the right anticipated threat levels. So when we talk about anticipated threat levels, then it's important to standardize the things. And the most commonly used standard for checking the performance of glazings for intrusion is EN 356 standard. Very common in Europe, and something similar to that is now happening in India also, in my country. And then we have the one standard in US, which is ASTM 1233. So this standard has different types of impacts. As you can see in the picture, the first we have the ball drop test is there. This is for very low level of security glazings. In this case, this 4 kg steel ball is dropped a number of times, and it is observed if it is capable of causing a penetration into the glass. And for high level of security glazings, the test is done by using this mechanized X, and the intent is to make a cutout in the glass, and the number of blows which are required to make out a cutout, these are recorded, and accordingly the glazing is given a rating. Then it's important to mention that, you know, when we are designing security glazings, not only the glass, but the framing is also very, very important, because otherwise, if you have got a very, very good security glazings, but if the frame is not properly designed, and the good security glass can actually come out of the framing, and the entire purpose gets defeated, you know. So it's important to test the window and the frame together, and the standards that you see mentioned on the right side of the screen, these can be used for testing the glass and the framing together. But for today, we are focusing on glass. So let's talk more about the standards on the glass and how this test is done. The ASTM standard 1233 standard is a standard which requires the impact on the glazing to be made with different kinds of tools, starting with blunt impacts like a sledgehammer or a pipe. Then it can have sharp tools like chisel hammer, angle iron sledge. As the threat level goes higher, you may have a requirement of thermal stress and chemical deterioration as well. Because when a mob is trying to attack the glazing, people can be very, very innovative, and they can attack the glazing with different means. And I have a video which I will just play in a few seconds. Yeah, but the intent is to stop the or increase the time and effort as much as possible. And the pass criteria that has been mentioned in the standard is if it is the glazing is capable of allowing a diameter rod of 3.3 meters, 3 millimeters rod can actually pass through the glazing, then it is considered as a failure. These are 2 criteria. And then we have a block of 200 by 200 mm. If this block is able to pass through the glazing, then it's considered as a failure. And then let me just show you this video. So this video illustrates that what happens in real time, that like people are attacking this glazing. This video is from New York. What happened last year after some incidents of civil unrest in parts of US, in New York and other cities. So this was a big fashion brand where people are trying to enter forcefully into the showroom because they want to loot. Yeah, so here we can see like a variety of tools have been used, starting with a hammer, and they are kicking the glass. So luckily it was designed with sentry glass, and that's why it was able to withstand all these attacks. The attack is being made by a firearm. Here we can see the different threat levels as per the EN 1063 standards. So this is a European standard which gives 7 different levels of different ammunitions, and the difference between these threat levels is the speed of the bullet and the size of the bullet. So BR1 is the lowest level and the BR7 is the highest level. And generally we get inquiries for the BR4, BR5 and BR6. These are the most commonly followed threat levels for important buildings. And then nose pawl is, as I mentioned before, like when someone is sitting next to the glazing, so there is a perceived threat of getting injuries from the glass or maybe from the small splinters of the glass, which might happen because when the bullet is hitting the glass. So the bullet may not actually go through the glazing, but because of the small splinters, people might get injured sitting next to the glazing. So there you need a no spall solution. So we have a solution for that as well, which we will see in the coming slides. But before that, let me just talk about the US standard, which is NIJ standard. So this is also one of the very, very common standard specified for important building specifications, level 1 to level 4. This has got 4 levels. And similar to that, we have the UL standard, which has 8 different levels. As we can see, the level 3 is very similar to what we saw in the previous standard, with EN 1063. This is like, if I have to talk in layman language, this is like AK-47 rifle ammunition, which is very commonly used by in terrorist attacks. Yeah. So what we hear very commonly from the industry is that, you know, there are some challenges with the existing solutions for the security glazings, that, you know, the materials that are used, they are not so durable, and so they have some issues with the weight of the glazings, because those glazings are so thick that it poses a challenge to the fuel efficiency of the vehicle. And of course, because you have a huge thickness of the glass, then it's a compromise with the optical quality of the glass as well. So scientists of Kuraray, they actually worked on resolving these issues, and so we came up with advanced interlayers which meet all the requirements of the customers, which have been highlighted to us. So thanks to our advanced interlayers, so we can make the BRGs or the security glazings, which have got a very long life because of the advanced interlayers, and they are lightweight, they improve the fuel efficiency of the vehicles, and also in buildings. So you have to you can fit the same glazing in lighter frames, and there is no compromise with the safety of with the transparency of the glazings. So they have got good optics, and of course they are easy to process for our customers. So here I have an illustration of the comparison between the conventional BRGs or the bullet resistant glazings made with the conventional materials. So they are quite bulky. They have durability issues, and they have got very low scratch resistance. So for that reason, they need to be replaced quite often. Although they have got a anti-scratch coating on that, but it's not good enough for the lifetime of the building. So then the advanced interlayers will help the BRGs. They become 15% lightweight. They are highly durable. They are high scratch resistance, and they have got a very high resistance against chemical attacks also, and they are easier to process. So you might be wondering, like, what's this Spall Shield CPET, which is mentioned over here. So this is a very excellent product from our portfolio, which is used for anti-spall solutions, which I mentioned before. So what it does, I will not say anything. I will just play this very interesting video, and you will understand very quickly what is Spall Shield. Yeah. So this is a video from one of our customers for a BRG application. So here we are trying to shoot bullets through the glass, and what you see is the striking face of the glass. So that you see the bullet hitting the glass and the splinters of the glass flying. And this is the protected side of the glazing. So the other side is completely safe because there are no splinters. So the other side is absolutely safe. So definitely the glass construction is stopping the bullets. But if we have to make the person sitting next to the glazings, you need to have this PET film, which we call as Spall Shield or anti-spall. So this actually, you know, helps make the glazing absolutely safe. So you saw the third bullet hitting the glass, and there are no splinters on the other side. So now you see the third bullet has also hit, but there are no splinters at all. So when we talk about lightweight glazings, so here is a comparison of the reduction in weight that can be achieved if advanced interlayers from Kuraray are used. So I have made this comparison for the NIJ level 3A and level 3. So with the conventional BRGs, as you can see, the glazings are quite thick. And if we talk about in terms of percentage, like, the maximum weight reduction in terms of percentage is 15%. And also, I came across one BRG solution from one of the leading manufacturers of glass. So they have a BRG solution for NIJ level 3, which is almost 67 mm thick. And our solution is 40% lighter than that. So that's a significant reduction of weight of the glazing if it is used in a building or in a car. When we talk about BRGs or the bullet resistant glazings being used in automotive applications, then it's very important to make sure that those glazings are absolutely durable against attacks of chemicals, which have been listed in these two tables, because the most of the automotive standards, they feel actually it's not only automotive, but even in case of buildings, often some chemicals are used to clean the glass surface. So it's important to make sure the glazing or the glass is absolutely resilient against attacks from these kind of chemicals. And so we have done a lot of testing for all these chemicals, and you can see the spall shield CPET has absolutely no effect, and its optical quality remains up to the mark even after exposure to these chemicals. It's a clear winner against the other conventional materials like polycarbonate or acrylic. Another type of security glazings, when there is a perceived threat of blast happening outside a building. So you need to design the facade against attacks from shock waves, which might be produced when there is explosion happening outside the buildings. So on the picture on the right hand side, you see two different test methods. The first one is the shock tube test, where you simulate the blast or the shock wave inside the lab. So it's possible to simulate that. And at the bottom, you see the photograph of a real bomb, which is exploding in front of a building. This building is making use of the glass specimens, which need to be tested for their performance against the shock wave. So if you have a very precise idea of the anticipated peak pressure and the impulse, then we can do the simulations for you in WinGuard software. So we will need this basic input from your side, and we can let you know the optimum glass combination that will help you achieve the desired performance. So when we talk about the desired performance, then what is that? So let me just move on to the next slide. So this is a pictorial illustration of the performance levels, which tells you that how you want the glazing to behave when there is an explosion happening outside the building. So the level 1 is the most safest level. As you can see, the glazing is not even broken. So the glass is intact even after breakage. And the level 2, glazing is broken, but it is retained in the frame. And level 3, the glass fragments have flown up to a distance of 1 meter from the glazing after breakage. And then level 3B is they can fly up to a distance of 3 meters after the explosion. And level 4 is definitely not the one of the safe levels, because glass fragments can go and hit anywhere. Yeah, so the most commonly used safety levels are actually level 2 and level 3A. Definitely you can design for level 1 also, but your client should be willing to pay for that. So if your client has the money, definitely we can suggest this combination also. But it's good to know that with Glass you can design the glazing to achieve very high performance levels, like level 2 can also be achieved for a pressure as high as 40 psi. So if I just go back and show you that I forgot to mention that these are the commonly followed pressure levels for important buildings. 10 psi is generally a very good pressure level that is considered for all the federal buildings in the US, recommended by Department of State for important buildings. But for even more important buildings, maybe like for, I'm just guessing, like if maybe the White House, maybe it might have been designed for a pressure of 40 psi or even higher. So yeah, so in those kind of situations, our products can help you meet the desired performance levels. And the spall shield can also be used to make it even more safer if you want to prevent this risk of injuries from the glass splinters. And this is my last slide. I'm just I'm going to just summarize the advantages of the security glazings which are made with advanced interlayers from Kuraray. So they have got the highest optical performance, as we have seen. Sentry glass, which is the most clear interlayer available in the market, and then we have spall shield, which is also having a optical clarity next to the glass. And then we have after years of exposure to the UV radiations, so these materials have a capability to retain their high optical performance after years of exposure to the UV radiations. And then we talk about the high resistance against weathering. Nature can be very, very cruel to any material. So we have tested our advanced interlayers like sentry glass for very high aggressive conditions, to the extreme conditions of Florida, where the laminates have been exposed to the harsh and high humidity conditions for more than 20 years, and we haven't come across any defects so far. And most importantly, it's important to highlight the performance of CPET or the spall shield interlayer. So it can withstand very high temperatures up to 16 hours as recommended by ISO standard 12543 part 3 standard. So this is a requirement for a normal laminated glass. So a BRG application made with the conventional materials like polycarbonate or an acrylic sheet, they cannot withstand this test, and that's the reason spall shield has a clear edge over the conventional BRGs. So that's why we strongly recommend this material to be used when you want your glazing to perform at all ranges of temperature. As we have seen before, our glazings are thinner and lighter. They can make not only the glazing lighter, but also the framing system which is required to install the glass, and after breakage the glass might have to be replaced after some time. So that also becomes quite easy if you have a lighter glazing installed in the framing system. Yeah. This was all from my side. Thank you very much.